Welcome back to Topic 45 for Algebra 2, Properties of Radicals and Solving Radical Equations. In Part 1, we're going to use properties of exponents to rewrite radicals, and also dive into some properties of radicals. Before we start with that, let's review exponential notation versus radical notation. As we've seen in previous topics, we know that exponential notation can be rewritten in radical notation. So for instance, x to the 1/2 is the same thing as the square root of x. Now the index here is 2, although because square roots are so commonly written, we actually don't write the index of 2 here. However, for the next example, x to the 1/3, we would write the third root of x. Moving along to x to the 2/3, this is the same thing as the third root of x squared, or you may see it written as the third root of x squared, where the exponent is included inside the radicand. If we want to generalize, this is the same thing if we have a to the m over n as the nth root of a all to the mth power, or the nth root of a to the m. Now in our next example, we have a to the negative m over n power. So if we think back to our properties of exponents, whenever we have a negative exponent, we like to move it. Here, this is in the numerator. In order to make this a positive exponent, we're going to bring this entire quantity down because it's attached to the exponent to the denominator to make it positive. So this is the same thing as 1 over a to the m over n. We can rewrite that in radical notation as 1 over the nth root of a to the m. And keep in mind here, a cannot equal 0. If we did have 0 in the denominator, then that would be undefined. Moving along to using properties of exponents to rewrite radicals. To rewrite the radical as a rational exponent, first, we can acknowledge that here we have ab, this entire quantity. If we have the nth root of ab, then this is the same thing as that same product, ab to the 1 over n, because this quantity on the left is really raised to the first power. Whenever we don't see an exponent, there's automatically a 1 there. Now we can rewrite using the power of a product property. So this ab to the 1 over n will be applied to every single factor, to the a and the b in this case. So we're left with a to the 1 over n times b to the 1 over n. Now we can rewrite these rational exponents as radicals. So a to the 1 over n is the same thing as the nth root of a, and b to the 1 over n is the same thing as the nth root of b. Since they still have a product here, we're still going to have multiplication in between them. Let's simplify an example. How can we rewrite the third root, or the cube root, of 16x to the 5th using properties of exponents? Well, what I want us to do here is to think about the factors. Specifically based on the given root. Here, our given root is 3. So if we look at our coefficient of 16, I want to think of the factors of 16, which factors would I be able to take the cube root of? Well, I know with 16 is the product of 8 times 2. So I can rewrite this as the cube root of 8 times the cube root of 2 times the cube root of x to the 5th. Moving along to the variable, how can I simplify that? Well, x to the 5th is the same thing as x times x times x times x times x. And again, if we keep in mind the properties of exponents, if they have the same base, then we add the exponent. So I can group these first 3 terms together and get x cubed, and then group these last 2 terms together and get x squared. So this becomes the cube root of 8 times the cube root of 2 times the cube root of x cubed times the cube root of x squared. Now I'm still multiplying these variables together, so the overall value of the expression has not changed. Now we can go through and simplify. The cube root of 8 is 2. Now the cube root of 2 we can't simplify, so I'm just going to leave it in radical form. The cube root of x cubed, since we have the index and it matches the exponent, they cancel each other out. However, this is the same thing also as x to the 3/3. 3 divided by 3 is just 1, but oftentimes we just don't write it. And the cube root of x squared we also can't simplify any further. Now we can rewrite this because multiplication is commutative, so we can flip the order. I can group my 2 times x together to get 2x, and then I can also group my cube root of 2 and the cube root of x squared. So my final answer is 2x times the cube root of 2x squared. Now let's get into some properties of radicals. Properties of radicals, we have multiplication and division. For multiplication, it's called the product property of radicals. For the product property of radicals, the nth root of a product is equal to the product of the nth roots of the factors. Okay, so what does that mean? So if we have this product of a times b, the nth root of a times b is the same thing as the nth root of a times the nth root of b. And this is written in radical form. We can also translate it to exponential form, where ab to the 1 over n power is the same thing as a to the 1 over n times b to the 1 over n. Similarly, if we want to deal with the quotient property of radicals, the nth root of a quotient is equal to the quotient of the nth roots of the factors. Here we have the nth root of a divided by b. Now this is the same thing as the nth root of a over the nth root of b. And again, we can also rewrite this in exponential form of a divided by b to the 1 over n to be a to the 1 over n divided by b to the 1 over n. Now let's use these properties to solve an example. In our example here, what is the 5th root of 16 times the 5th root of a in reduced radical form? Now reduced radical form, I'm going to go back to this slide, was how our final answer was written here. So that is what our final answer here should look like in reduced radical form. According to the product property of radicals, the nth root of each of these factors is equal to the nth root of the product. So I can multiply these two radicands together. 16 times 8. Now that's equivalent to the 5th root of 128. Now remember what I said beforehand about thinking about factors. I want to think about factors of 128 where I can easily take the fifth root of those factors, or at least one of them. Now 128 I can think about as 32 times 4. So the fifth root of 128 is the same thing as the fifth root of 32 times the fifth root of 4. Now the fifth root of 32, that's a number to the fifth power gives me 32, which in this case is 2. And a lot of these kind of common roots will become easier or muscle memory just with more practice. Practice makes progress. And here we have the fifth root of 4. Now this can't be simplified any further, so we're just going to leave it in that radical form. And this is in reduced radical form. That was part 1 of topic 45 for Algebra 2, Properties of Radicals and Solving Radical Equations. Thank you for watching.